The question I have is, could you talk about the structure of soil? If you recall, in another video, we talked about forces between particles of soil. We noted that in coarse-grained soils like sand, all we have are mechanical forces between two particles. Whereas in clays, in addition to the mechanical forces, we also have what are called the physico-chemical forces. There are two types of those, the van der Waals attractive force and the double layer repulsive force. The van der Waals attractive force is what is responsible for cohesion in fine-grained soils like clays. So let's keep these in mind when I talk about the structure of soil. In a clay soil, sometimes the particles are arranged like this, and other times the particles are arranged like this. And this type of structure is called flocculated structure, and this type of structure is called dispersed structure. In a dispersed structure, particles are more parallel than in a flocculated structure. This usually occurs when the original soil was formed in a salty water, like in a marine environment. On the other hand, dispersed structure forms in a freshwater environment. For the same number of particles, a soil with a flocculated internal structure is more porous than the soil with a dispersed internal structure. This has implications to water flow. This is more permeable than this. Also, this is stronger than this. I also want to point out that this type of soil is more anisotropic than this. That is, properties in the vertical direction will be different from the properties in the horizontal direction. So if I were to list the variables that control properties of a clay soil, there would be the Voigt ratio, anisotropy, and structure. So these are the three key parameters, but then of course there are a few others that have smaller influence. For a sandy soil, we know there are no physico-chemical forces between particles, so we don't have anything like a flocculated or dispersed structure. But the particles can be arranged in an anisotropic manner, and therefore the properties are a function of the Voigt ratio, anisotropy, and a few other things, including particle-to-particle friction, which we have in clays as well. So it's a bit more simpler than in the case of clays. So to sum, as a result of physico-chemical forces between clay particles, the internal structure could either be flocculated or dispersed. Because the physico-chemical forces are functions of not only the type of clay but also the fluid in between, the structure depends on where the soil was initially formed. If it is formed in a marine environment where the water is salty, then the structure tends to be flocculated, whereas in freshwater environment, the structure tends to be dispersed. Whereas something like that is not relevant to sand because there are no physico-chemical forces between sand particles. So the structure tends to be fairly simple. Let me also talk about peculiar or poor soil, which is related to the structure. These are the type of soil that could pose challenges in the design. A site containing a denser sand is better than a site containing a looser sand to build structures on. This is because a loose sand has low strength and highly permeable to water flow. These properties govern the behavior of a structure subjected to a static loading. You may have to densify the soil or use a more expensive pile foundation. We have a more serious problem when the structure is subjected to a dynamic loading like an earthquake loading. And in this case, the site might completely liquefy. That is, the saturated sand in the site could turn into a liquid, like it happened in many places in California during the past earthquakes. For example, during the Loma Prieta earthquake of 1989, there were many sites in the Marina district in San Francisco experienced liquefaction. And this led to numerous failures of apartment buildings and gas stations. The remedy might again be densifying the sand or using pile foundation. In clays, one of the difficult ones are what is called sensitive clay. Supposing, say, we have a clay soil that was millions of years ago formed in a marine environment. As we have seen earlier, in this environment, the clay tends to form a flocculated structure. And say at some point, the sea retreated and this clay soil became a land. Then over the years, rainwater seeped through the soil, leaching out the salt. The salt has ended up in sea now, so the salt content of the site is very low now. Whereas in the original site, the salt content is very high. But the internal structure doesn't change immediately, so it still contains a soil with a flocculated structure. The structure, therefore, is no longer consistent or compatible with the fluid chemistry. This type of soil is what is called a sensitive soil. So what happens is, as long as you don't disturb the site, the strength of the site remains high and the site remains stable. But when there is a disturbance, like some form of vibration or an earthquake, then this flocculated structure collapses. When it collapses, there could be a landslide. So this type of clay is what is called the sensitive clay. An extreme form of this is what is called a quick clay. Many parts of Canada and Scandinavian countries like Norway have this type of clay, quick clay. Over the years, there have been some major landslides, and let me show you a video on this. In the first part of this video, see the landslide that will initiate in this part of the quick clay
had to run for
and
his life.
spread to a larger
In his
area,
own words,
swallowing
a wave of
several
earth
houses.
came rolling behind me. An eyewitness recounts, suddenly an area of about 150 by 200 meters, including the old school building, sank down and moved monolithically towards the lake. The sliding mass didn't move through the existing slide scarp, but in the direction of the terrain slope. Most of the slide debris flowed into the lake, while some came to a stop in a compression zone close to the shoreline. A new large gateway had now been opened into the lake. The persons living on this farm behind the new steep slide scarp escaped with private cars just before the farm slid out. The persons living on this second farm were warned by their escaping neighbors and managed to get away just before their houses were taken by the slide. Back on safe ground, our amateur photographer again started his camera just in time to film a new large flake-type slide.
In this video, you're going to see after the collapse of a quick clay embankment, the clay flows like a river, dragging houses and other things along with it.
Large flakes of dry crust, in some cases with intact buildings on top, floated on the remolded quick clay stream. A second amateur photographer, who had heard about the landslide, had rushed for his camera and found a safe position on the hillside from which he started filming the last portions of the slide activity below him. Sliding masses moved in the direction of the slope, hit the lower rim of the slide scarp, and were forced to flow to the right towards the lake.
Here's the URL for this video.